Alright, let's start. So today is the last lecture for this course, and we'll take this time to review everything we've learned so far. First, at the beginning of this course, we were introduced to the programming model. The traditional one is should be waterfall, or the term plan or documentation, where it's basically borrowed from traditional engineering field, like building a machine, like building a building, building a bridge, that kind of thing, where it usually follows the waterfall process, where gathers requirements, like if it's a building, what is the purpose of the building? Is it for for school, for office, for housing? Those are decided first, and then you get, based on that, you have the design, exterior design, interior design, and then with that, then you get blueprint. You figure out how to run all the pipes, all the cables. You decide what kind of material you need to use in order for it to sustain the weight of the building itself. Those are the examples. And then with the plan and document, it's then handed over to construction, where the construction workers execute the plan and actually build it out, right? So that's the traditional waterfall procedure. Oh, and then lastly, it's tested, reviewed, and then usually someone will visit the site and make sure it's complying to whatever standard you need to meet. When it comes to software engineering or developing a software, initially it's borrowed from this idea, where we figure out the requirements, make the plan, make the design, and then build it out one by one. So, and lastly, test it and go through QA process, stuff like that. And once it's delivered, it's done. And then it will be difficult to modify it. Similar, for example, a building, once it's delivered, if you want to modify it, depending on how different it will be, sometimes it can be really hard. For example, if you want to turn a school building into an office building, or from an office building to something residential, then it's going to be really, really difficult to remodel that. The thing is, for software, it's usually relatively easier to modify it, and then after modifying it, it's usually easier to release it and roll it out, right? And throughout the course, we've been talking about doing agile is really to empower the project to be able to adapt to changes, and then changes are actually something in the nature of the software mostly. Although there are some sort of certain type of software that don't really need too much changes once it's developed. So that's another story. Really, the point is to exploit the possibility of making changes in software after it's released or deployed. So that's the idea. And then with that, we introduced Agile, or more specifically, it should be called extreme programming, if we choose all the practices we've learned so far. But otherwise, like for example, pair programming, if we just look at Agile from the project management practices, like pair programming usually is not really required. So by doing all that, I would say it's rather extreme programming or extreme project management rather than Agile. But it's just a term. So depending on how you define it, it can be interchangeable. Okay, so that's the beginning of the course. We introduced everybody with this concept, and the real problem we try to address in software engineering is really trying to find a way to maximize the productivity, right? Given that you have X amount of programmer, developer, let's say 5, how can we best utilize this team to deliver as many features as possible? And also on the business side, to deliver the most relevant, most important features as early as possible. So that's one main thing we try to address in software engineering. And then to maximize it, that's why we need to introduce some of the engineering principles and also some of the project management tool, right? Because if you look at project management, it's really additional communication overhead, honestly. But by doing that, by spending some effort to communicate, what we eventually want to gain is to gain productivity. Same for the entire procedure, like through planning, through documentation, through early upfront designing, figure out specifications, all that. Really, we are trying to trade off some time to gain more productivity, to gain time elsewhere. So the naive way or the imperative way is just no project management, don't follow any project lifecycle, just do as we go. That's also an approach. And sometimes when a project is really urgent, you see, and then when resources are limited, you will see, people will go imperatively to just right at the beginning is try to attack the project without maybe even clarifying all the requirements and all that. So in general, no planning at all, no management at all, it's usually bad. And then usually more issues will surface once you pass beyond a certain point. But also on the other side, with the traditional approach or the waterfall approach, we kind of put too much stuff up front, right? Too much planning up front. Maybe it's a 2-year project, right? So let's say we spend 10%, 20% amount of time, effort up front to plan everything, to think through all the details. Then that we're looking at like 2 months, 4 months period of time doing nothing, just planning. Although it's important doing planning, sometimes it's just from the business side, it may not make sense, right? Rather than spending that amount of time planning, maybe we could already release the first version of the application. And sometimes time is really important, and for certain projects, time can be really sensitive. So also by planning everything ahead, some of these planning may not really need to happen that early on. Let's say the project has several phases, right? Let's say a 2-year project, it can be broken down into 4 phases or 4 major milestones, as we've talked about in last lecture. Then maybe the first is to launch a user-facing website, and then the second milestone would be maybe launching an administration portal, which is not supposed for designed for user, is really for few administrators of the website or the application to interact, right? And then the third phase might be, adding a quite independent component or module to the site, so forth and so on. So sometimes it may not be really necessary to plan out all the details, although I would admit sometimes details that seems irrelevant, right? Maybe some feature in the admin portal may seem irrelevant, has nothing to do with the application, the user-facing application itself. But cases are down the line you realize, hey, actually there's some code related, and also depending on your design pattern, code smell, something can be coupled for no good reason, but it's just because of the code is bad. But that happens by implementing some changes to the admin portal. Unintended bugs would happen, but that's another story. So what I want to say is really the point, the problem we try to address here is just maximize the productivity. So to do that, some planning is for sure required, and at least some minimum planning and designing up front. It's really, really necessary. But also some may not be that necessary. So there we are, like, depending on the scope of the project, maybe it would make more sense to go with the more traditional waterfall approach. For example, if the project is not that big, and if it's manageable, like within a small team, which can be delivered, for example, in a quarter, like 3 months, usually then it's probably better just plan everything ahead, which, let's say if it's a 10%, we're looking at roughly 2 weeks, right? 2 weeks of planning. But if it's rather a longer period of time, like a 2-year project, 5-year project, then it's really unnecessary to plan everything ahead. So that's why we introduce Agile as part of the practice. We basically do short iterations rather than plan everything. We plan step by step. So for each iteration, we decide what we want to work on and then plan only that part of the application. So basically, to maximize productivity, the idea is to do careful planning and documentation and design. For waterfall, just do everything up front. For Agile, we just do shorter iterations. The other good thing by doing that is we minimize the risk of miscommunication, right? So by delivering part of the software, certain piece of the application, we can get immediate feedback from the user or from the client or from the the product owner, stakeholder, whatever we call it. And then we can get immediate feedback. Whereas for waterfall, it's usually it would usually take longer to get feedback here. And also human beings are just prone to misunderstanding. until the actual user that touches the actual product to use it. It really, it's usually really difficult to get actual accurate feedback from the user. Even with some techniques like mockup, right, wireframe, what we talked about, or that lo-fi storyboard, that kind of thing. It's a good way to communicate, but still, until the user actually touch that, the finish the product, you never know, like some miscommunication can happen. So by going with shorter iterations, which is part of agile practice, we will also minimize the risk of miscommunication, and then hope in turn minimize the expected time required for refactoring. So there are some pros and cons there, right? By not doing all the design upfront, it kind of increased the risk of poor design, because some feature that we haven't planned yet might have a big impact on how we would structure the code base, right? How we would design the design pattern. And then that's actually the problem that was brought up in one of the videos, I think, last week. So by doing agile, we take less time planning upfront, but also meaning we have to embrace the risk of poor design because of that. But at the same time, we minimize the risk of miscommunication and possible time required for refactoring because of miscommunication, of course. So there's some pros and cons, and also depending on the project, one may outweigh the other. So you may want to think about that when you make a decision. All right, next. The other minor, I would say still important, but relatively minor problems we try to address in software engineering is how do we ensure quality. But to ensure quality is really about improving long-term productivity. So it's still kind of part of the first problem we try to address. And then depending on the project, sometimes long-term productivity may not be an important thing, especially for experimental projects. So that's also something you need to consider when you decide how to go about in terms of the project lifecycle and pick and choose the practices. But anyway, to address long-term productivity, the solution or the practices are really still planning, designing up front, but also through code reviews and testing, QA testings. And then that's pretty much the traditional approach if we think about code review and QA testing. So we test after the fact, and then we review after the code is done. And then the idea for Agile is if we need to do that, then we might as well make it mandatory, right? So to make QA testing mandatory, we do BDD and TDD. We basically write test code before we write the actual implementation. And then for code review, instead of reviewing that after the code has been written, we have pair programming where two pair of eyes look at the same code at the same time while the code is being programmed. So that's the idea. I would say in general for code review, let's first look at the traditional approach for code review. Personally, I have some experience doing code reviews. Sometimes code review can be useless. Even for me, I honestly, when doing code review, when I'm busy with my own tasks, I would just I would just roughly browse through the code and hit the check mark and accept the pull request. Because I'm busy doing something else. So unless there's some really obvious issue or bug that was caught, otherwise, like code review, I would say it's not really that effective. It's effective in preventing some obvious bugs and issues, code style issues, and it can be effective when a senior team member is reviewing the code produced by a junior developer. But still, there are tricky bugs that can be hard to catch with just simply code review. Of course, code review is not really primary to cover all the bugs, because testing is another big part of that. But still, like, there's a argument can be made about how effective code review is. But on the other side, like pair programming can be really, really effective, because those programmer that's in a pair, they should be really active while producing the code, hence preventing some difficult to catch bugs. And then for QA, I think really, actually we will look at QA after that. So to address that, we introduced the idea of code review and QA, and then in terms of agile, it's converted into pair programming, BDD and TDD. All right, and next one. Make better estimates. So making estimate is really part of the planning and project execution phase, where you're making estimates and then you track the progress of the estimates, right? So without those, it's actually really difficult to make estimates. Especially I've experienced talking to getting proposal from outsourcing companies for certain IT projects, and usually the first red flag I will see is for a company after I described what we're looking for. After I sent them the documentation of our requirements, there are company just confidently say, hey, we can do it, without any question or without anything to clarify. That kind of thing is usually a big red flag, because for all software projects, there's always something to be clarified, and there's always a question to be asked. So without those, and then just give like empty promises, that's just a big no for me. Same idea here. So for software projects, one of the big problem is like, how do we make good estimates? First, like we need to have good documents and the planning so that we can have a good understanding of the true scope of the project, right? And then we make an estimate from there. So if we just do that, then that's the waterfall approach. So again, we address that by careful planning and good documentation. But for Agile, the idea is, hey, human beings are just bad at making estimations. So let's just estimate as little as we could, right? So we just do the estimation for the iteration, the task included in the iteration, and then we don't estimate the time. Rather, instead we estimate the point, and then we have a system to over time track how many time we spend for each point. So there's a point or an argument to be made for this system, and I personally haven't yet tried it. It sounds good, but practically how good it is, I'm not really sure. And honestly, sometimes making estimate based on just make direct time estimates may not be that bad. At least for me, I think. Of course, there are some error here and there, but it's just not that bad, honestly, as long as the scope is clear. So, but anyways, the agile approach is first, don't estimate for the entire project. We just estimate for the next iteration, and then we don't estimate directly the time, but rather make estimate based on points. So that's how we try to address this problem in software engineering. And next, which I have already mentioned, it's really about how to exploit the nature of software so that we can adapt to changes. One of the bonus that comes with software is we can make changes compared to build a building, compared to build a bridge, compared to build a device, where once it's produced, once it's delivered, it's really difficult to make additional changes. So for software, we can and we should make changes because the requirements usually changes, the needs of the user usually change. So the question is, how do we adapt to that, right? How do we better exploit it? How do we modify the procedure so that we can make changes effectively? So then for waterfall, because it's borrowed from traditional engineering field, so although it can still somehow by defining a maintenance phase, we still can somehow make changes to the delivered software. But the downside is it usually comes with high cost of maintenance. So the idea from Agile is, hey, let's change it. Let's do some of the practices we've mentioned, TDD, refactoring, design pattern, so that we can make sure the software is relatively easier to be changed later without breaking other stuff. But actually, on the other side, like for TDD or for testing, it's also applicable for waterfall procedure, right? Because we still need to write tests. It's just we write tests after the software has been produced, and then when we make change, then even with waterfall, we still have testing that are available that we can use for regressions. So that even with waterfall, still it's not really unlikely that we will break anything as long as the testing, we have appropriate testing in place. And then same idea for waterfall. It's actually we usually produce better design patterns during the waterfall procedure because we design everything up front. So I would say personally, the main value here from Agile is for TDD to mandatory the tests, to make tests required. Because usually in waterfall, when the deadline is coming close, people just skip tests. Whereas in Agile, if we make tests mandatory, then we ensure that when the software is shipped, it ships with tests. And then for refactoring, a similar idea. But I would say the real value that's brought here is really just make testing required in the lifecycle. But otherwise, for waterfall procedure, it still does pretty much the same thing. All right, so next we will go through every single practices one by one. Sorry. First, we talked about how to learn a new language, and we were introduced a 8-step plan. I would say, yeah, you can go with that, but I personally go with the following plan. It's really just take the first hour, learn the basic syntax of the language, which includes how to define variables, how to define methods and functions, how to declare, define a class, how do we do inheritance, how do we do mixing or composition, or module, whatever you name it. What are the types of data, how a string looks like, string, number, array or list, hash or object, stuff like that. And then what are the other stuff? How do we import a module? How do I that's usually pretty much it, I think. Spend first hour, go through the syntax, and then really know where you can find the document of that syntax, how to Google it. Really learning that is important, because I don't think it's feasible to memorize the syntax of each programming language you would use in your life. So whenever you forget it, the only thing you really need to know is how to Google it. And then once you can find it, you can usually just copy and paste. So the idea is really spend the first hour learning the syntax, variable, function, methods, and also loop, how to do loop, how to do conditional clause. That's pretty much it. And then usually every single language on their homepage, they come with a get started tutorial where it goes through the basic syntax for you. Right, so you learn that, and then in a day, so in an hour, learn the syntax. In a day, use that syntax, to write some code, and then probably the next thing is to learn to figure out the version management. How do I install a specific version of this language? Because you never know which version of the language it will be using for certain projects. So you really need to find the management tool to manage the versions effectively. So for example, in Ruby, we've introduced RVM for Ruby Version Manager. And then for the first week, introduce the language. You probably would spend some time learning how to manage dependencies, how to incorporate open source libraries, and then really whenever you have a feature, something to implement, unless it's really tied to your business logic. Otherwise, it's almost always some open source library already out there implementing that. For example, how do I parse a date time string? It's usually handled either with some built-in stuff or a library, right? How do I do sort? Although, like in SE or I mean ECS or IT, when you pick the data structure and algorithm course, you would always the first course is how to do sorting. But really, in engineering, in production, like in your work, you don't really have to do that. You just find a library. It's either also again either built-in or someone else would have implemented in an open source library. So what's next is really figure out how to incorporate open source libraries, and almost always all those popular programming languages have some tool to manage dependencies, manage packages. So for Ruby, it's bundler, and with bundler you can install and manage all the gems, right? For Node, it's npm or yarn, and then for everything, pretty much all the language has something like that. And then the next step would be like in first month, after figuring out that, spend time getting comfortable with writing code, and then probably already have something functional in your project. Then it's really learning the idioms, how the language, what's the unique way of this language implementing certain things. Right, for Ruby, there's stuff like metaprogramming, and especially for Rails, we have certain patterns, certain opinions on doing certain things. For JavaScript, it's different because it's event-driven language. So you will see callbacks everywhere. But these days, it's probably better to use like promise-based or async await style. And then for some other type of languages, like Java, which is statically typed, then it's also different in doing certain things. What else? Like Go language put emphasis on concurrency. So it also has its own way doing concurrent stuff, where other languages like Ruby, Python, you probably want to do like multi-threading to handle concurrency. Yeah, there are numerous examples here, so I won't just go through all that, and I think I will get to some of those later. So these are usually the steps involved learning a new language. Yeah, and then we will get to next one. So after learning a language, where we used Ruby on Rails, Ruby as an example, next we talked about pair programming versus and code review. So the trade-off here is by doing code review or by doing pair programming, we are basically tasking somebody to do some extra work by reviewing the code and pairing with the other programmer, right? So the idea is to sacrifice some short-term productivity to make both parties learn what's going on with that piece of code, and to ensure the quality of the code, which in turn will improve the long-term productivity. And then programming is also good for knowledge transfer. So sometimes you may not want to do all the way pair programming, right? But you may do some pair programming. For example, if it's a critical part of the system, then you may want to have two pair of eyes look at it. Also, if there's a new member onboarded, you may want to use pair programming to transfer the knowledge to get the new programmer get started with the help of the team. Yeah. And then we were introduced of some architectural pattern, which is called SOA, or service-oriented architecture. And then one specific implementation of that is microservices. And then in order to do microservices, you need to implement RESTful API. So we were introduced of that. And then the counterparty is usually the monolithic architecture. So the trade-off here is basically